Again, now keep in mind that we are using our understanding of all these geometric concepts, such as angle measures and side lengths and the Pythagorean theorem, to help us solve problems. So here we have safety rules state that a 16-foot ladder leaning against a building should have an angle of elevation no less than 75 degrees. If a 16-foot ladder leaning against a building has its footing 4.5 feet from the base of the building, determine if this ladder violates the safety rules. So a couple of things to point out right away. This has an angle of elevation right here. And an angle of elevation is if we have a horizontal line and an angle from that horizontal line is going upward, this winds up being the angle of elevation right here. And for this particular problem, it says that it can be no less than 75 degrees. So I have a graphic here that kind of represents this. As you can see, we have a ladder that's leaning against the wall here. It has a base that's 4.5 feet from the wall. That's this right here. The length of the ladder, that's 16 feet. It's a 16-foot ladder. So obviously what occurs here is it creates a right triangle. So if I was to label each one of these angles, maybe I'll label this one down here as angle A. Then this one have to be angle B. And of course, angle C is where the right triangle is formed. If this is angle A, then the side opposite over here, that's got to be side A. And if this is angle B, the side opposite over here, this has got to be side B. And of course, side B is equal to 4.5 feet. The hypotenuse, that's the length of the ladder here, that's 16 feet. The angle of elevation is right here. If this angle is less than 75 degrees, then we know that this ladder setup is in violation of the safety rules. Now, trigonometric ratios, the trig ratios, they help us determine side lengths. Their inverses help us determine angle measures. So since we want to find the angle measure, we wind up using the inverse. So I need to determine the measure of angle A. And of course, I look at what information is provided to help me determine what type of ratio I should have. So I have this information here, 4.5 feet, and I have this information here, 16 feet. What is this information in relationship to angle A? It's adjacent to it. What is this information here in relation to angle A? It's the hypotenuse. So the adjacent over the hypotenuse, that's cosine, except we're not going to do just plain old cosine. We're going to use cosine inverse because we're trying to determine an angle measure. And the inverse looks like cosine or sine, whatever the case may be, is raised to the -1 power. And that's going to be side B over the hypotenuse. So this is the cosine inverse of 4.5 over 16. So now that I have that, I just use my calculator to help me determine it. So on your calculator, I use the TI-30 calculator. Here we have sine right here, and just above it, we have sine inverse. Most scientific calculators will have this type of setup. Cosine here, and just above it is cosine inverse. And then I have tangent here, and just above that is tangent inverse. Now we want to make sure that we are in degree mode. I am in degree mode. If I'm not in degree mode, I have to go to my mode key, switch it to degree mode if it's in any of the other modes. But we are in degree mode. So then all I have to do is go to second in order to activate cosine inverse and hit cosine inverse. You can see as it comes in. Then put in 4.5 divided by or over 16, and then close off that parentheses. That's approximately 73.67 degrees. So the measure of angle A is approximately 73.67 degrees. 73.67 degrees is less than the 75 degrees, so the latter is in violation of the safety rules.